Electricity is all around us, powering technology like our cell phones, computers, lights, soldering irons, and air conditioners. It's tough to escape it in our modern world. Even when you try to escape electricity, it's still at work throughout nature, from the lightning in a thunderstorm to the synapses inside our body. But what exactly is electricity? This is a very complicated question, and as you dig deeper and ask more questions, there really is not a definitive answer, only abstract representations of how electricity interacts with our surroundings. Electricity is a natural phenomenon that occurs throughout nature and takes many different forms. In this tutorial we'll focus on current electricity, the stuff that powers our electronic gadgets. Our goal is to understand how electricity flows from a power source through wires, lighting up LEDs, spinning motors, and powering our communication devices. Electricity is briefly defined as the flow of electric charge, but there's so much behind that simple statement. Where do the charges come from? How do we move them? Where do they move to? How does an electric charge cause mechanical motion or make things light up? So many questions. To begin to explain what electricity is, we need to zoom way in, beyond the matter and molecules, to the atoms that make up everything we interact with in life. Electricity is created by generators which can be powered by gas, coal, oil, wind, or solar. The electrical energy can be converted into other types of energy such as light, heat, movement, or sound. Electricity is dangerous, so be careful when using electrical appliances. Before we get into this point, we'll consider the levels of organisms we learned before. To understand the fundamentals of electricity, we need to begin by focusing in on atoms, one of the basic building blocks of life and matter. Atoms exist in over 100 different forms as chemical elements like hydrogen, carbon, oxygen, and copper. Atoms of many types can combine to make molecules, which build the matter we can physically see and touch. Atoms are tiny. Even the atom isn't small enough to explain the workings of electricity. We need to dive down one more level and look in on the building blocks of atoms: protons, neutrons, and electrons. An atom is built with a combination of three distinct particles: electrons, protons, and neutrons. Each atom has a center nucleus, where the protons and neutrons are densely packed together. Surrounding the nucleus are a group of orbiting electrons. Electricity is defined as the flow of electric charge. Charge is a property of matter, just like mass, volume, or density. It is measurable. Just as you can quantify how much mass something has, you can measure how much charge it has. The key concept with charge is that it can come in two types: positive, plus, or negative. In order to move charge we need charge carriers, and that's where our knowledge of atomic particles, specifically electrons and protons, comes in handy. Electrons always carry a negative charge, while protons are always positively charged. Neutrons, true to their name, are neutral, they have no charge. Both electrons and protons carry the same amount of charge, just a different type. Electrostatic force is a force that operates between charges. It states that charges of the same type repel each other, while charges of opposite types are attracted together. Opposites attract, and likes repel. The amount of force acting on two charges depends on how far they are from each other. The closer two charges get, the greater the force, either pushing together, or pulling away, becomes. Thanks to electrostatic force, electrons will push away other electrons and be attracted to protons. This force is part of the glue that holds atoms together, but it's also the tool we need to make electrons, and charges, flow. We now have all the tools to make charges flow. Electrons in atoms can act as our charge carrier, because every electron carries a negative charge. If we can free an electron from an atom and force it to move, we can create electricity. Now consider a copper wire. Matter filled with countless copper atoms. As our free electron is floating in a space between atoms, it's pulled and prodded by surrounding charges in that space. In this chaos, the free electron eventually finds a new atom to latch onto. In doing so, the negative charge of that electron ejects another valence electron from the atom. Now a new electron is drifting through free space looking to do the same thing. This chain effect can continue on and on to create a flow of electrons called electric current. Metals and alloys. True metals are pure elements, while alloys are blends of two or more metals that have been melted together. A mixture contains two or more substances that are not united chemically to form a compound. An alloy is a mixture of metals that may also contain nonmetals. Alloys behave as metals. Alloys are made because the properties of the mixture, such as, for example in strength or corrosion resistance, are superior to the starting materials.